So all metals try to lose electrons. So always metal surface will be rich in electrons, right? When metal surfaces are rich in electron, if I take any chemical outside, if it possesses cations, that cations try to approach and take those electrons and convert into H2. Possible or not? Correct? So in short, I'm writing that in this way. When an metal rod, when a metal rod is immersed in its metal ion solution, I will represent this metal ion solution as M plus N aqueous, and I am representing this metal rod as M, right? So when a metal is immersed in its metal ion solution, an electrical double layer is generated at its interface. Interface means boundary. Potential difference between thus developed electrical double layer is called electrode potential. I am explaining the same point in a different way. Observe this. I am considering one metal rod. Listen carefully, sir. I am considering one metal rod. Right? I have connected that to any terminal, maybe positive or negative, any terminal, right? And I immersed this metal rod in its metal ion solution. Means if it is silver rod, I need to immerse that in Ag plus aqueous. Zinc rod, Zn plus 2 aqueous. Copper rod, copper plus 2 aqueous. Same way if it is M, then M plus N aqueous. Right? Now, I call this as phase boundary. This is the boundary between solid rod and aqueous solution. Right? I am writing that as this as that boundary. Outside that, what you have? M plus N. Inside this, what you will find? M, metal. We know all metals are electropositive. Means every metal tries to lose electron. All those electrons gets accumulated on the surface of this rod or not? So what is the overall charge accumulated on the surface of rod? Negative charge. Now inside the rod, definitely M plus N ions will be there. inside this rod, M plus N ions will be there. Outside the rod, again M plus N ions are there. Correct or not? These M plus N ions try to pull these electrons. Then what about these ions which are present inside the rod? They also try to pull these electrons. Correct? Then what happened? Do that electrons move in any net direction? So they will remain on the surface. Right? Now, as they remain on the surface, outside the rod, M plus N ions also keep on trying to pull those electrons. They also remain outside that as a layer. Correct? Yes, sir. This rod is rich in electrons now. Because of those electrons, outside the rod, M plus N ions are there. Those M plus N ions are trying to pull those electrons. So they also start accumulating around the rod. Right? Now we got one layer here. What is the charge of this layer? And what is the charge of this layer? So you got an electrical double layer at the boundary or not? Now there is potential difference, positive layer, negative layer. Difference is there. That potential difference is called. Any questions? Now read that statement carefully. When a metal rod is immersed in its metal ion solution, an electrical double layer is generated at its interface. Potential difference between thus developed double layer is called electrode potential. Clear? Any questions, sir, in it? No. According to IUPAC, International Union of Pure and Applied Chemistry, right? This electrode potential should be mentioned by using certain symbol, right? So to mention that, they always preferred a reduction potential as a reference, and it is called standard. Electrode potential was standardized, right? Electrode potential was standardized. So to show that, they took a reduction as a reference. Clear? So how they are going to show that? This is metal, so I will write as M. This is metal ion, M plus N aqueous. Now these two are present at a boundary, phase boundary or interface. So interface is indicated by a single vertical line. So what is the meaning of it? There is an interface between metal rod and metal ion. Correct? So conversion of metal to metal ion is oxidation process, no? But what IUPAC said, we have to represent that as a reduction standard. So how I have to write this as reduction in standard means exchange these two. If I exchange these two, what I will write? M plus N aqueous is trying to convert into M. That is the meaning of it. M plus N is trying to convert into M. M plus N is trying to convert into M means it is trying to gain electron. Gain of electrons is called reduction. So that's why IUPAC said reduction potentials or electrode potentials. You always try to mention in this way. Is it clear? I can mention in this way also. But according to IUPAC, I need to mention them always in this manner. We call that as standard reduction potential. Clear? Any questions in that? So I am repeating. According to IUPAC, according to IUPAC, reduction potentials are standardized. Reduction potentials are standardized. The moment I call this word standard means concentration of the metal ion must be taken as 1 molar. Temperature of that solution should be at to 98 Kelvin. Pressure should be taken as 1 bar, right? At a pressure of 1 bar, at a temperature of 298 Kelvin, at a concentration of 1 molar, whatever the potential difference you found, that is taken as standard potential. That too, it should be represented only by reduction. So I will write always it as M plus N aqueous 1 molar interface metal solid. Is it clear? This is the representation of reduction potential. If I interchange these two, then I call it as oxidation potential. Clear? Response, sir. Right? Symbolically, I will write this as E naught M plus N to M. And what is E? Electromotive force. Units of electromotive force is voltage. Correct? So reduction potential. No? So for potential, I am using a symbol E. Naught represents standard. M plus N to M represent reduction. So this is reduction potential, standard reduction potential symbol. Is it clear? Response, sir. Any questions, sir? Online, do you have any questions in it?
No, sir.
Now the challenge is how to measure them. Challenge is how to measure them. If I want to measure something, what we discussed, we need to have upper limit, lower limit. If I am not able to fix boundaries, I cannot measure anything. Or a starting point, ending point, or at least I need to find a starting point. Then only I can measure something. Na? What is the length? What is the length of this room? What I have to do? I need to find a starting point and I need to find a ending point. Otherwise, I cannot measure the length of it. Correct or not? Same way, if I want to measure standard reduction potential, something must be there. From there, I have to start. If I start from somewhere, I have to give that starting point value as 0. Correct? Yes or no? Now, as I am measuring reduction potential, something's reduction potential, I have to take it as 0. Then only I can start. Right? So we call that as a reference electrode. What we call it as? So to measure reduction potentials, I have to take something as a reference and I have to give a value 0 for that. By comparing with that, I will measure reduction potentials of others. Right? So what IUPAC suggested is take hydrogen electrode. This is called hydrogen electrode. Take this hydrogen electrode as a standard, give a value of 0 for it. With respect to that, measure reduction potentials of remaining all. That's why we call this as standard hydrogen electrode. Is it clear? So according to IUPAC, which is taken as the reference electrode? Which is taken as reference electrode? Hydrogen electrode. So I call it as standard hydrogen electrode. So she. Who is reference means? She is reference to measure electrode potential. Clear? What is she? Standard hydrogen electrode is the reference. And what is the value of it? 0. So I will write as E naught of H plus 2 H2. Why I am writing H plus 2 H2, sir? Reduction has to be taken as standard. Correct? This value is taken as 0.00 volts. Then what is its oxidation potential? Oxidation potential, that is also 0. How I have to write oxidation potential of it? Just to simply exchange these two. Correct? Response, sir. If I write this as E naught of H plus 2, sorry, E naught of H2 to H plus. I am writing H2 gas, 1 atmosphere or 1 bar, interface H plus, aqueous, 1 molar. Are you able to understand why I am writing all this? The moment I write not, what is the meaning? Standard means pressure must be 1 bar, concentration 1 molar. Correct? Right? Instead of writing this, simply I will write this also. Then you need to understand that. You need to understand that. Right? So what is this value? 0. We call this term as, what do we call it as? Standard oxidation potential. SOP, correct? This is called as standard reduction potential, SRP. Correct, sir? So this is SRP of she, that is SOP of she. Clear? Any questions in this? No. Sir, I want to measure electrode potential of this M in M plus, or silver in Ag plus, zinc in Zn plus 2, or copper in copper plus 2. What I have to do? Bring this and connect to she. Right? Bring that electrode, connect it to she, and check that voltmeter reading. Whatever the reading shows, that is the potential value of this. Clear? Any questions? Here also any questions? Sir, how to symbolically represent this? I am symbolically representing this as, according to IUPAC, which it has to be connected as reduction. Correct? Reduction means H plus should convert into H2. So I am writing that in this way. H plus aqueous 1 molar interface H2 gas 1 atmosphere or maybe 1 bar interface platinum. Either I write as hyphen platinum or interface platinum. So why you are writing in this way? Hydrogen is a gas, right? If hydrogen is a gas, how come gas will have interface with H plus? H2 gas always try to escape. That's why what I have taken a platinum plate. I have considered a platinum plate. On the surface of that platinum plate, they created a boundary between H2 as well as H plus. H plus is having boundary with platinum. H2 is also having boundary with platinum. And H plus is trying to convert into H2 on the surface of platinum. That is the meaning of it. H plus is trying to convert into H2 on the surface of platinum. Clear? Instead of platinum, you can take copper, you can take any other metal. But platinum doesn't interfere in any reactions. No? That's why it is called inert electrode. So on the surface of inert electrode, we are bringing that electrode. Clear? We call this as standard hydrogen electrode, or we also call this as reference electrode. Correct? Why we call it as reference electrode? Because we gave an reference value of 0 for it. It may have some value, but I don't know. Right? Whatever the value it had, I will take that value as 0. With respect to that, I will compare with the remaining all. Any questions? Response, sir? No. Determining, next slide, determining electrode potentials. Now you know what is electrode potential. Now we are seeing how to measure it, right? Determining electrode potentials. Right? Now observe how I am determining. Tell me how to measure electrode potential. Connect that with C. Over. Right? I am taking one image. Observe this image carefully. What we have done? What we have done, sir? Zinc rod immersed in zinc nitrate means Zn plus 2 ions. So zinc rod immersed in Zn plus 2 ions is connected to C. Correct? The standard hydrogen electrode. Platinum wire. Outside H plus ions are there. And we are passing H2 gas into it. Means over the surface of platinum, there becomes phase boundary between H2 gas and H plus ions. Clear? Any questions? And what should be the concentration of this H plus? 1 molar. What should be pressure of this H2 gas? 1 atmosphere or 1 bar. Right? I will do one thing. Everywhere I am writing 1 atmosphere. Now here also let me write it as 1 atmosphere. Then there is no questions. Right? 1 atmosphere means 1.01325 bar. Means approximately same only, na? So no much variation. Clear? Right, sir? Now, how to write this symbolically? Right? To write this symbolically also, they have given one standard procedure. Whichever you are writing on left side, we have to assume generally it as anode. Whichever you are writing on right side, we have to generally assume that as cathode. Means which is cathode here? She is cathode and anode. Zinc rod is anode. Now both are connected through something. We call it as salt bridge. Salt bridge is symbolically given by two vertical lines. Symbolically, salt bridge should be written by using two vertical lines. Now see this, how I am writing this. This is anode. At anode, what should happen? Generally, oxidation happens at anode and reduction happens at cathode. Na? The cations go towards cathode. Anions go towards anode. The cations are positively charged. They are going towards cathode means cations are attracted or not. If cations are attracted means what is the charge over this? Negative. So negative charge will be taken by cations. So cations are taking negative charge means what is happening? Reduction. Gain of electrons is called reduction. Clear? So I am representing this as zinc rod interface Zn plus 2 aqueous 1 molar. Why I have written that? Zinc converted to Zn plus 2 oxidation, because on left side what I have to write? Anode. I have to write anode at left side. At anode always oxidation should occur. Between salt bridge Salt bridge is indicated by double vertical line. Clear? Salt bridge is indicated by double vertical line. After that, cathode. What should happen at cathode? Reduction. So H plus aqueous concentration of 1 molar interface. Interface, then H2 gas, pressure of 1 atmosphere, again interface platinum. Symbolical representation of this diagram. Everywhere drawing diagram is time consuming, so we simply write this symbolic way. Clear? Now, what this represents? This represents anodic half cell. This represents anode. This represents cathode. And this represents salt bridge. What happens at anode? Oxidation. What happens at cathode? Reduction. Clear? Understood? Right? Now I am writing that again in a reaction way. Cathode. What should happen at cathode? At cathode always reduction occurs. At cathode always reduction occurs. At anode always oxidation occurs. Right? Now reduction means gain of electrons. Reduction means gain of electrons. Now tell me which is undergoing reduction? Hydrogen or zinc? Hydrogen. Whichever represented on right side. Right? So I am writing that 2H plus aqueous gain 2 electrons to produce H2 gas. Correct, sir? Is it reduction or not? Reduction or not? No. At anode, what should happen? At anode, what should happen? Oxidation. Oxidation means loss of electrons. Means which should lose electrons? Zinc. So I am writing that zinc solid gives rise to electrons plus Zn plus 2. Tell me whether it is oxidation or not. Right? Say something. Now, what is overall reaction? What is overall reaction? Can I call this overall reaction is redox reaction or not? Why, sir? Both oxidation and reduction occurs simultaneously. Means every cell reaction is a redox reaction. Every cell will have anodic half cell, cathodic half cell, both put together one full cell. Right? Anodic reaction means oxidation reaction. Cathodic reaction means reduction reaction. Overall cell reaction is always a redox reaction. Clear? Right? Now tell me, what is overall reaction? Can I cancel these 2 electrons and these 2 electrons? Now tell me, what is overall reaction now? Say, sir, what is that overall reaction? Zinc solid plus 2H plus gives rise to H2 gas plus Zn plus 2 aqueous. Correct? Okay, again I will write that. This is overall reaction. Or this overall reaction is nothing but a redox reaction. We call this as cathodic half reaction, anodic half reaction, oxidation half reaction, reduction half reaction. Clear? Any questions in it? No. Tell me this. Yes, sir. Why? To close the circuit. Or if this is not there, circuit is not closed. Na? I need to Electrons has to flow. Electron has to flow means I need to close the circuit or not. Otherwise, if circuit is not closed, no flow of electrons. Now, how can I say two things are connected? If one is losing electrons, right? Those electrons has to come back, no? Then only circuit is closed. If the salt bridge is not there, what happens? No flow of electrons. Correct? Response, sir. Right? So role of salt bridge is to close the circuit. Right? Anyhow, we will discuss about that salt bridge in detail. Clear? Now come back to this. This is overall reaction. Now, this reduction will have some reduction potential or not? This is reduction means it has some reduction potential. So I write as E naught H plus 2 H2. Correct? Huh? For this, what I will write? E naught Zn2 Zn plus 2. What is this value? I don't know. What is this value? I know. Correct? Huh? Now for this overall reaction also, there will be overall voltage of this cell. That overall voltage of this cell is shown here. So this is E naught of this cell. Overall voltage. What is that E naught of cell? 0.76 volts. Right? That's what I have seen in this reading. Clear? Means E naught of cell is equal to E naught oxidation plus E naught reduction. E naught of cell is nothing but E naught oxidation plus E naught reduction. What is E naught of cell here? 0.76 volts is equal to what is E naught oxidation? E naught of Zn to Zn plus 2. Correct? This is oxidation. Response, sir. Plus what is E naught reduction? E naught of H plus 2 H2. Which value is 0? This value is 0. Therefore, what you got? Therefore, E naught of Zn to Zn plus 2 value is 0.76 volts. But according to IUPAC, I have to show reduction. But what is this one? Means E naught of Zn plus 2 to Zn means I need to reverse it. If I reverse this, what will be the value? Value also gets reversed. No? How I will reverse it? How I will reverse it? Exchange these two. Or exchange these two positions. Keep hydrogen electrode here and zinc electrode here. Means indirectly I have exchange. Then what happens to reading? Reading, direction of flow of current becomes reversed. If it becomes reversed, what happens to this value? Gets reversed. Correct? So instead of plus 0.76, now I will get minus 0.76. So minus 0.76 is the reduction potential. Clear, sir? Do you have any questions in it? Do you have any questions in it? No, no? Now I am taking one more example. Copper, solid, no, better I will reverse it. Platinum, interface, H2, gas, 1 atmosphere, interface, H plus, aqueous, 1 molar, salt bridge, copper plus 2, aqueous, 1 molar, interface, copper, solid. What you understood? What you understood, sir? Huh? Standard hydrogen electrode is taken as anode, copper electrode is taken as cathode, right? Then what should happen here? And what should happen here? For this overall cell, E naught of cell is given as plus 0.34 volt. Means what is the meaning of it? Overall, if I connect this, I will get a value of 0.34 volts here. That means what is the meaning of it? That is, here what I have to write? E naught of H2 to H plus E naught of copper plus 2 to copper is equal to 0.34 volts. Correct? What is the value of this? 0. Means E naught of copper plus 2 to copper is 0.34 volts. Is it reduction or oxidation? So I calculated reduction potential directly. Why? I have connected this towards cathode only, na? Means I will get reduction potential only. If I have kept that here and this value there, then I will measure oxidation potential value. Clear? Respond, sir. Now I am taking one more example. One more example. Zinc, solid, Zn plus 2, aqueous, 1 molar, interface, copper plus 2, aqueous, 1 molar, interface, copper, solid. I want E naught of cell value. What is E naught of cell equal to? E naught oxidation plus E naught reduction. What is this one? This is anodic compartment, right? This is cathodic compartment. At cathodic compartment, what should happen? Reduction. At anodic compartment. Respond, sir. Correct? So what I will write E naught of this cell as is equal to E naught of Zn to Zn plus 2 plus E naught of copper plus 2 to copper. Correct, sir? Say something. Right? Now see this. E naught of Zn plus 2 to Zn value is minus 0.76. But what we need to substitute here? Same or different? Check. This is Zn plus 2 to Zn means it is reduction. But what is happening here? Oxidation. Because we are taking it as anode. So I need to substitute oxidation potential, na? Correct? So what is its oxidation potential value? Plus 0.76 volts. Plus same 0.34 volts. Total 1.01 volt. Correct? So if I connect zinc rod immersed in Zn plus 2, copper rod immersed in copper plus 2, what should happen? A voltage of 1.10 or 01? 10. 1.10 volts is generated. So we created a 1.1 volt battery. Yes or no? Is it 1.1 volt battery or not? Right? Now, oxidation is happening, right? Correct? Now see this. At anode, oxidation occurs. Oxidation means gain of electrons or loss of electrons. Which has to lose electrons? Which metal? See, zinc metal has to lose electrons. Correct? Correct or not? So I am writing that. Online, respond. So zinc is losing electrons. Any questions? Right? No. At cathode, what should happen at cathode? Huh? Reduction. Now tell me, which has to undergo reduction? So copper plus 2 should gain electron now to form copper. Right, sir? Correct, sir? This is called as galvanic cell. What do we call it as? If I connect voltmeter, I call it as voltaic cell. If I connect galvanometer, I call it as galvanic cell. Voltmeter will measure voltage, galvanometer will measure current, I. Right? Whether you are measuring I value or whether you are measuring voltage. Right? So simply I am typing galvanic cell. Right? Observe galvanic in brackets, voltaic, both are same only. What is the difference? If I am measuring voltage, I call it as voltaic cell. Correct? I will take a better diagram. No, copper and silver, this is no. I want zinc and copper only with that value in it. I see that value 1.1 volt. Is there any such diagram with 1.1? No diagram, huh? See, sir? Value is there? There is something wrong in this diagram. Tell me that. Which is wrong? The diagram is wrong. You will not get that value as 1.1. You will get that value as minus 1.1. Here, zinc is taken as cathode. If zinc is taken as cathode, I will get the value as minus 1.1. So diagram is wrong. Correct or not?
Sir, zinc is taken as anode only now, sir, in that.
Hey, see that cell representation? In which direction you have taken that zinc? Oh, sign they have changed. Huh? Where? Okay. No. Hey. They gave the sign negative, no issue. But standard, according to rules, anode should be written on which side? According to rules, I have to write anode on left side and cathode on right side. So according to the rules, the diagram is wrong. But they have given the symbol minus here, plus here. That's why it became correct. You able to understand? If they have not given this symbol, and if they have not given the direction of flow of electron, diagram is wrong. Are you able to understand? Better to avoid that confusion, we will take zinc on left side and copper on right side only. See such diagram, man. This is better diagram compared to all. Wait, they have given written something there. I don't want that name. Shall I take this one? Tell sir, do you have any questions in this diagram? Do you have any questions in this diagram? Perfect, huh? A representation also check, man. Zn plus 2 aqueous, copper plus 2 aqueous, copper. Correct only, na? If they don't mention it as 1 molar, then it is not standard. So they have to mention 1 molar, 1 molar here. Temperature also should be given as 298 Kelvin. Pressure also should be kept at 1 bar, 1 atmosphere pressure. Clear? Response, sir? No. Among these two rods, which is losing electrons continuously? Zinc rod is losing electrons continuously, and zinc rod is converting into. So this zinc rod is converting into Zn plus 2. Correct? Huh? And it is losing electrons. Now, where it left those electrons? It has to left those electrons on the rod itself. Zinc has to go to Zn plus 2 aqueous. Zinc is solid. Zinc solid should convert into Zn plus 2 aqueous, means it has to dissolve. Right? While it is dissolving, it has to lose electrons over the rod itself. If it leave electrons on the surface of the rod, what happens to the charge of this rod? That's what they have given. Negative. Zinc is leaving electrons on the rod and going out as Zn plus 2. So what happens to electrons on the surface of the rod? Increases. Therefore, what is the charge of the rod? Negative. Correct or not? We called this as anode or cathode? Anode. So what is the charge of anode now? Correct, sir? Correct, sir? Right? Now, what is happening here? Copper plus 2 is pulling electrons. Copper plus 2 is pulling electrons out of the rod. Correct? Copper plus 2 is gaining electrons to form copper. So copper plus 2 is pulling electrons out of the rod, and it goes and deposits on the surface of this as copper. If copper plus 2 is pulling electrons, what happens to overall electrons on the surface of this rod? Decreases. If electrons decrease, what will be the charge? That's why it is shown as positive. So what is the charge of cathode? Right? Now tell me, charge of these rods are because of what? Do the chemicals taken inside the cell are responsible for charge? Or do I created charge by connecting them to positive terminal, negative terminal? Chemical energy is responsible for charge over the rods. Correct? Respond. Now, among this rod and this rod, which is rich in electrons? Zinc rod. So that's why observe the direction of flow of electrons. Electrons are flowing from zinc rod to copper rod. If a direction of flow of electrons is from anode to cathode, what is the flow of current? Cathode to anode. Clear? Any questions? Response, sir. So I am writing that here. Electrons flow from cathode to cathode to anode or anode to cathode? Flow from anode to cathode. What is the charge of anode here? What is the charge of anode here? Negative. What is the charge of cathode? Positive. Correct? Response, sir. And what about direction of flow of current? Can I simply write here itself, which is opposite to direction of flow of current? or better I will write here itself. Here itself I will write comma. Therefore, current will be in opposite direction to flow of electrons. Correct? Huh? Means that is from cathode to anode. Any questions? Again, one more point. What happens to the size of zinc rod? Reason? It is dissolving to form Jan plus 2. What about size of copper rod? Increases. After some time, what happens? Why that equilibrium is reaching? Why no more reaction is taking place? Again, listen carefully. If a zinc is going into this solution, what happens to concentration of Zn plus 2? Then what is the charge of the solution? Charge of solution becomes more and more positive. If solution becomes more and more positive, do this solution will allow electrons to flow? Are you able to understand? If the solution becomes more and more positive, do this will allow these electrons to flow? Will not allow. Correct? Means flow of electrons is stopped or not? When flow of electrons is stopped, electrical current. Now, as concentration of Zn plus to keep on increasing, what is the ability of these electrons to flow? Then what happens to this reading? So that reading slowly becomes less and less. At some point, becomes 0. When that voltage becomes 0, we said, why we call it as equilibrium? When voltage is 0, why we call it as equilibrium? There is no flow of electrons. Means electrode potential this side and this side became equal. Means they reached equilibrium, balanced on both directions. Clear? Are you able to understand? Sir, I will not make this Zn plus 2 gets accumulated. I will keep on removing this Zn plus 2. Then also reaction will stop after certain time. Reason, zinc rod is over. And if I keep on removing the Zn plus 2, man, if I keep on removing Zn plus 2, what happens to the size of rod? Decreases. After certain time, rod is over. Zinc rod is completed. If zinc rod is completed, then also reaction has to stop, no? Right? So whatever I do, finally this has to reach equilibrium. Voltage should approach 0. Are you able to understand? Clear? So I am writing that point. Size of anode decreases and cathode yes, ma'am. And cathode increases. Anode decreases, cathode increases. Right? Any questions in it? After certain time, equilibrium is attained. Now tell me this. Initially, what is the concentration of Zn plus 2 here? As the time keep on changing, what happens to concentration of Zn plus? Means it is no longer 1 molar now. If it is not 1 molar, I should not call it as standard. If it is not standard, whether I have to write E naught or simply E, means After certain time, equilibrium is attained. When equilibrium is attained, whether E naught of cell is 0 or E of cell is 0. Clear? Are you able to understand? Because it is no longer 1 molar. If it is no longer 1 molar, I should not write it as E naught. Right? So equilibrium is attained, that is E of cell becomes 0. Clear? It is no longer standard condition. Are you able to understand? E naught will never be 0. E naught will be always same value. 1.1 volts only this for this. As time proceeds, concentrations keep on changing. When concentrations keep on changing, voltage keep on decreasing. When voltage keep on decreasing, finally I will say E of cell, but not E naught of cell. Any questions? Clear or not? Understood now? So now you are familiar with electrode potential, right? Now, for all different metals or for all different types of chemicals, they connected everything to standard electrode, standard hydrogen electrode, and they've calculated all those values and they kept all those values in one table. We call that as electrochemical series, right? Electrochemical series. I don't want all this. I want only NCRT. See, sir. Right? So next side ready. What is it? Next heading, sir. Electrochemical series. Now tell me what is electrochemical series? Right? We are not arranging everything. Few. Right? If you keep on writing everything, this page is not sufficient. Right? So few things are taken as a reference. Most commonly used things are taken as a reference and they have written all of them at one point. Right? Which is taken as a reference to measure electrode potentials. So observe hydrogen value. Response, sir. Yes or no? Whether this is taken as reference or not. So with respect to this, we are measuring. Why I have to write again? I will write this as over now. No. With respect to this, those who are possessing positive values, what are they all? Reduction potential values are positive, means they are undergoing reduction spontaneously. They are willing to undergo reduction. If reduction potentials are negative, means they are willing to undergo oxidation. Sponsor, I see already we have seen here. Zinc, what we got? Reduction potential negative. For copper, reduction potential positive. Voltage value is positive, means when Gibbs free energy you studied in thermodynamics. Let me write that also. I am writing that point. Note, according to thermodynamics, delta G naught is equal to minus NF E naught. Right? If E naught is positive, Then what about delta G naught? If E naught is positive, then what about delta G naught? Negative. For any spontaneous process, gypsy free energy must be, right? So spontaneous process should possess E value positive. Clear? I am removing this not, means at any condition, not only standard, at any condition. Correct? Response, sir. So at any condition, if E is greater than 0, then what about delta G less than 0? Then this process is spontaneous. Means if E reduction is greater than 0, if E reduction is positive, that means reduction is spontaneous. If E oxidation is positive, if E oxidation is positive, oxidation is spontaneous. Clear? If reduction is negative, oxidation is spontaneous. Again, man, if E reduction is negative, if E reduction is negative, oxidation is spontaneous. If E reduction is positive, reduction is spontaneous. Don't get confused. Correct? Any questions in it? Now see this. Observe all these values. These reduction values are very high. All these have very high reduction potential values or not? Or I say something, right? I am taking water as a reference here. Or find where H2O is present. Here, H2O is present here, na? Correct? Means aqueous solutions definitely should possess H2O, right? So in aqueous solutions, all these are undergoing reductions spontaneously. Say something. Compared to water, these are all less than water, but E reduction values are positive. Means they are all undergoing reduction spontaneously. Right? Now, compare to water and compare silver, which undergoes reduction spontaneously. Correct or not? Or O2 is undergoing reduction more readily than silver. Correct? Oxygen is undergoing reduction to form water more readily than silver. Yes or no? Means in presence of water or in presence of oxygen, atmospheric oxygen is always available. No? If I take any solution, atmospheric oxygen always dissolve in water, right? So even in presence of atmospheric oxygen, if anything is undergoing reduction more readily, that means that is better. It is undergoing reduction readily means it is better oxidizing agent than oxygen in water. Sponsor. All these are undergoing reduction readily. I am undergoing reduction means I am gaining electrons. From where I will gain electrons? From you. Means I will pull electrons from you readily. Means I am undergoing reduction. Means what happens to you? You are undergoing oxidation. I am responsible for it. Therefore, I am a good oxidizing agent. Is it clear? So all these are good oxidizing agents, even in presence of O2. Even if I dissolve O2, with respect to O2 also they are better oxidizing agents. Clear? Right? So they are very strong oxidizing agents. What about these? These are moderate. What about these? Weak. These are moderate oxidizing agents. These are weak oxidizing agents. These are very strong oxidizing agents. Correct or not? Any questions in it? Respond, sir. Right? Now tell me, what about this? Here also I am taking water. Below water. What are these? Right? They are good oxidizing agents. Therefore, these are, now instead of saying good, we can call strong reducing agents. Strong reducing agents. These are strong oxidizing agents. Strong oxidizing agents, they themselves undergo reduction. Strong reducing agents, they themselves undergo, right? Readily undergo. Readily undergo. They are strong reducing agents. So they will reduce others. They are getting reduced means I am undergoing. So they readily undergo. Here they readily undergo. Right? Right? Huh? Now see this. In presence of water. In presence of water. Among these two. Means, for example, I am taking aluminum and water. I am taking aluminum salt in water. Aluminum salt in water means Al plus 3 aqueous. Clear? Aluminum salt in water. Now I want to make aluminum to undergo reduction. Water also should undergo reduction. Among these two, which will undergo reduction readily? Correct? These are all strong reducing agents. So they readily undergo. Among water and aluminum, which will undergo oxidation readily? Aluminum. Which will undergo reduction readily? Water. Oxygen, aluminum is undergoing oxidation readily means above aluminum. Water is there, no? So water will undergo reduction readily. Means, is it possible to produce aluminum metal from aqueous solution? I am repeating again. Listen. No, listen carefully. Listen carefully. I am doing electrolysis of, listen sir, don't write. I am doing electrolysis of K2SO4 aqueous solution. Means I dissolved K2SO4 in water. I kept two metal plates. One is connected to positive terminal, one connected to negative terminal, one connected to cathode, one connected to anode. And I passed electrical current. Right? Okay, well? Now, what are the cations available in it? K plus, SO4 2 minus, correct? And also H plus. Why, sir? Water is there, na? From water, H plus is also generated because enthalpy of formation of H plus is 0. Enthalpy of formation of H plus is 0. Means when I am writing H plus, no need to talk about any energy. Directly I will write H plus. Correct? So H plus ions are also available freely. Now, water is also available. Correct? Correct, sir? Right? Now, I am taking cathode. Cations move towards. Cations will be attracted towards cathode. Means among K plus and H plus, both are attracted towards cathode. I assume this is negatively charged terminal. Assume that as negatively charged terminal. So K plus ions go towards negative terminal. H plus also undergoes goes towards -10. So K plus try to gain electron to form K. H plus also try to gain electron to form H2. Correct? So what are these? Reductions or oxidations? Reduction. Correct? Huh? Now compare H plus and K plus. Among these two, which undergo reduction readily? See the values, correct or not? So what I told you, these are all strong reducing agents. So they themselves undergo oxidation readily. So K plus undergo oxidation readily than H plus. Means which will undergo reduction readily than H plus. Not K plus, na? Among H plus and K plus, which will undergo reduction readily? H plus. So whichever is above in this series, they undergo reduction readily. Whichever is below in the series undergoes oxidation readily. Now I am comparing H plus and K plus, which undergoes reduction readily. Means this reaction will occur, this won't occur. Correct or not? Means is it possible to extract potassium metal by doing electrolysis of potassium salts in water? Is it clear? Clear or not? Means all these metals are impossible to extract from electrolysis of their aqueous solutions. Is it clear? So I am writing this point. They cannot be extracted by electrolysis of their aqueous solutions. Any questions online? Do you have any questions in this?
No, sir.
Means if I want to get sodium metal, whether I have to dissolve NaCl in water or I have to melt NaCl. Whether I have to dissolve NaCl in water and do electrolysis, or without adding water, I have to melt them and I have to do electrolysis. So if I want to extract aluminum, magnesium, sodium, calcium, potassium, lithium, I have to take care, water should not be there. Right? In absence of water only, I have to do electrolysis process to get that metal. Metallurgy. Clear? Any questions? Now come back to above. If I want to extract these anions, again I should not use aqueous solutions. Reason, compared to fluorine, which will undergo reduction. These are all good oxidizing agents. They undergo reduction readily. Correct? They undergo reduction readily. Now, if I want to do oxidation, I don't want to do a reduction, man. I want oxidation. If I want to make them to undergo oxidation, is it possible to make them to undergo oxidation in presence of water? No. So in presence of them, water will undergo oxidation readily. So they cannot be obtained at anode during electrolysis of their aqueous solutions. Same way, these cannot be obtained at cathode. Correct or not? Cathode or not? These cannot be obtained during electrolysis of their aqueous solutions at cathode. In the same way above, these cannot be obtained during electrolysis of their aqueous solutions at anode. Clear? Any questions? Respond, sir. Understandable or not? I will not make more complicated. You will understand now by looking at this point. Can you understand the above point? I don't want to write more and more points. Right? Based upon this, you can predict this or not. Right? Right? Based upon their potentials. If I am doing electrolysis process, do some cations or some anions are preferred than other ions? Or for example, I am taking aqueous solutions having H plus ion and Na plus ion. Among H plus ion and Na plus ion, which is undergoing reduction preferably? Correct? Means there is some preference is there. If I provide different cations, do all the cations will undergo reduction at the same time, or preferably among them someone will undergo readily? Correct or not? We call this as preferential discharge potential. Are you able to understand? Preferential discharge potential. Clear? Or preferential discharge of ions. Or discharge means removing charge. Right? Preferential discharge of ions means if there are many types of ions present, among them, one ion is selectively discharged. Once that is over, next ion will be discharged. Once that is also over, next will be discharged. Means they all follow a proper priority order. Is it clear? Any questions in it? Why this priority order is decided? Based upon electrode potentials. Clear? Any questions? So I'm writing that side heading. Preferential preferential discharge of ions. Now, I am roughly giving some cations, sir. I am roughly giving some cations, right? Tell me this. Randomly I am giving, sir. H plus, Pb plus 2, Ag plus, Au plus 3, Sn plus 2, nickel plus 2, lead plus 2, iron plus 2, aluminum plus 3, magnesium plus 2, sodium plus 2 plus calcium plus 2, potassium plus, copper plus 2. Now tell me, among these all cations, if I move them towards cathode, among all of them, which undergo reduction readily? Okay, check. Observe Au plus 3. Where is Au plus 3, man? Here it is Au plus 3 or not? Au plus 3 is above H plus or not? So when Au plus 3 and H plus is present, which will win the competition? Now, after Au plus 3, do Ag plus is there or not? Oh, what is it? Now, Ag plus. Is it above H plus or not? Correct? Means among all of them, which will win the competition? Au plus 3. After that, you want better, I will do one thing. Let me keep that here so that you can see and compare them. Tell them which is best, first preferred. So this is 1. Next 2. Then Fe plus 2 I am saying. Here what is it? Fe plus 3 converting into plus 2. I am asking Fe plus 2 converting into Fe. Now tell me which is priority 3. Copper? Where? Copper plus 2 is above H plus or not? So third will be copper plus 2. Then fourth, H plus. Very good. Now fifth, lead, Pb plus 2. 5. Then Nicola, tinna, tin means this is a 6. Then nickel 7. Then I wrote lead 2 times. Okay. Then Fe plus 2. Say something. 8. Now which is 9 among them? Al plus 3. Correct, sir? So this is 9. After that 10, 11, 12, 13. Are you able to understand? So if I keep all these cations in one water and if I apply one metal and I connect that metal to negative terminal, then in what sequence they will go towards cathode means? First, gold will go and deposit. After that, above gold coating, you will find silver coating. Above silver coating, you will find copper coating. Above copper, hydrogen gas will evolve. After hydrogen gas got evolved, lead coating. Are you able to understand? After lead, are you able to understand this? So do they follow certain sequence or not? Right? Are you able to understand the meaning of it now? Preferential discharge order. All ions will not be discharged with same capacity. Understood? Online? Say something. Understandable or not?
Yes, sir.
18 students are there earlier. Now 16. 2 people left already. Now see this. Among cations, what is the discharge order? What is the discharge order? Au plus 3 better than Ag plus better than copper plus 2 better than H plus responder better than lead better than tin better than nickel. After that iron. After that iron. After that aluminium, magnesium, sodium, calcium, potassium, lithium. Correct? Correct or not? In them, among them, they can never be reduced in aqueous solutions. Yes or no? Reason? Their values are more negative. Are compared to remaining all, their values are more negative or not? Correct? So they can never be extracted from their aqueous solutions. Correct? Never be extracted from their aqueous solutions. Is it necessary to explain anions or can I write that order directly? Understood or not? In the same way, anions also, no? So, same way, anions. Now, series, sir. In cations, whichever cation is at the bottom in the series, that is discharged weakly. Correct? So, among cations, whichever cation is on the top in the series, that is reduced readily. Now, instead of cation, if I take anion, whichever anion in the bottom of series will be oxidized readily. Again, see, among cations are positive. The cation which is above in the series will be reduced readily. Similarly, the anion which is above in the series will not be oxidized. Cation which is above in the series will be reduced. Instead of cation, I am taking anion. Anion has to undergo oxidation, right? Anion which is present in above in the series, will not be oxidized. Correct or not? Means among all anions, which anion cannot be oxidized? Iron. Oh, sorry. Fluorine. Fluorine can never be oxidized. After fluorine, I am talking about only anion, sir. I'm talking about only anion. These are all reduction potentials, man. I'm taking anions means I have reversed all the values. Are you able to understand? This series is reduction potential series. I'm taking anions. Cations I have to reduce. Anions I have to oxidize. If I want to oxidize, I have to reverse all these equations. If I reverse all these equations, what happens to all these signs? All the signs becomes negative. Correct? Response, sir. If reduction sign is more negative, if reduction sign is more negative, it will not undergo reduction. K plus is not getting reduced. Correct? If reduction sign is more negative, it is not undergoing reduction readily. Correct? If oxidation sign is more negative, it will not undergo oxidation. Correct? Correct or not? If I reverse all these reactions, then what happens to all these signs? Negative. Then oxidation sign is more negative for fluorine. Means fluorine will not undergo oxidation. Understood or not? Yes or no? Right? Now tell me, among all these anions, which anion undergo oxidation readily? Anion. I am talking about which anion? Not cation, man. Anion. Which anion undergo oxidation readily? Means oxidation potential value must be more positive for anion. Correct? So check which anion is having more positive value. Observe. Is there any anion here? Observe, man. All these are anions or cations? Cations. I am talking about anions. Anions. Check anions. Check anions. Anion. Here. Anion is there or not? Iodine is also there. Okay. Anion. Iodine is there. So among all anions, which anion undergo oxidation readily? I minus. After I minus. After I minus. Br minus. After Br minus. Cl minus. After Cl minus. F minus. Before F minus. H2O. To form H2O2. Yes or no? H2O converting into H2O2. H2O converting into O2. Correct? Compared to Cl minus, H2O can undergo, compared to Cl minus to Cl2. Compared to Cl minus converting into Cl2. H2O can convert into O2 readily. Compare this and this. Compare those two, man. Cl minus to Cl2. What is that value? Minus 1.36. H2O converting to O2. Minus 1.23. Correct? Correct or not? If negative value is more, then it will not preferably undergo oxidation. Now, which will undergo oxidation readily? So, if I have chlorine, means NaCl in water. If I dissolve NaCl in water, NaCl gives Cl minus ions or not? So, Cl minus ions has to go towards anode. Cations move towards cathode. Similarly, anions will move towards anode. So, Cl minus ions has to go towards anode. Water is also there. So, which will go towards anode readily? Water or Cl minus? As long as water is there, Cl minus ions do not undergo oxidation readily. Clear? Understood or not? Right? But every time comparing these values is somewhat tough. So that's why what we do is just remember that sequence. Not for everything. 4 or 5 ions. If you remember, that is enough. Right? Here also how to remember. No need to remember everything. Simply remember silver, gold, silver, copper, H plus. Remaining all are less than H plus only. So whatever they give, in presence of aqueous solutions, what I will do? Hydrogen gas I will produce. Only I will check whether they have given gold, silver, copper. If they give gold, silver or copper, I will use them. Otherwise, I will always produce H2 gas. In the same way for anions also, right? Directly I am showing that order. Preferential discharge of ions. Observe. In preferential discharge of cations, which is discharged readily. Observe this, what they are saying. Down, it is increasing, correct? So, which is discharged readily? Gold, silver, copper, H plus. We have written same order or not? Right? Among anions, which is not discharged readily. Correct or wrong? Right? But in the table, SO4 2 minus is not given. They have not given in the table. If they have given, that also comes in the order. F minus, NO3 minus, Cl minus, Br minus, I minus, OH minus also they have not given in the table. If they give water, where water comes? Say something. Water comes in between or not? Just now we have seen. Water comes in between Cl minus and Br minus, correct? Say something, sir. Correct? If they give OH minus, but in this table there is no OH minus. See, check. Is there any OH minus in the table? Either this side or that side. Check anywhere OH minus is given. No. If they have given OH minus will be exactly in the bottom of the table, correct? That's why that is preferred. So I am writing that order. Anions. Tell me the order, sir. OH minus greater than I minus greater than Br minus greater than H2O greater than Cl minus greater than NO3 minus greater than SO4 2 minus greater than F minus. Say something, sir. Understandable or not? Clear? If you understand this, one chapter is over. Metallurgy. One chapter is over. If you understand this small idea. If you understand this small idea, electrochemical cell is over. Electrolytic cell is also over. 2 parts over. Means 50% of the chapter is over. Just if you understand this idea. That's enough. If you understand this idea, enough. Electrolytic cell part is over. Electrochemical cell part also over. Then, do we have any questions in it? Say something. Do you have any questions in it? No? Right? No questions now? Now see this. Electrolytic cell. I am starting the second part of this chapter. Electrolytic cell. What I told you, after conductance and conductivity, we need to discuss about electrolytic cell, then the electrochemical cell. To understand electrolytic cell, some basics you need to understand. That basics I have completed. Now we will start studying electrolytic cell. Right? Any questions? Shall I start? Now see this, sir. In electrolytic cell. Take two metal plates, connect one to cathode, connect one to anode. Over. Then I call it as. Means by using external power source, if I pass electrons into the solution, then I call it as electrolytic cell. By using external source, external battery or DC current, if I am allowing electricity to pass through the solution, then I call it as electrolytic cell. Any questions? Clear? Now see this. I am taking example, one diagram directly. We have taken battery. This battery connected to one metal. Another negative terminal of battery is connected to another metal. Right? Assume two metal plates. They gave it as inert electrode. Na? Inert means that rod will not participate in the reaction. So generally, what may be that rod? Platinum rod. Right? So inert electrode. What do you mean by inert electrode? Inert electrode means do not interfere in cell reaction. Example, platinum. We call that as inert, right? So platinum plate or platinum rod connected to battery, another platinum rod connected to another terminal of battery. Generally, this small line indicates negative terminal and this larger line indicates positive terminal. So this is positive terminal of battery and this is negative terminal of battery. A rod connected to negative terminal of battery will be negatively charged rod. If I connect that to negative terminal, this will be negatively charged or not. So this rod is negatively charged, correct? And this rod is positively charged. So this is positively charged. This is negatively charged. Now tell me, which is responsible for charge over that metal plate? External source, battery, correct? Earlier, which is responsible for charge over the rod? Chemical reaction is responsible for charge over the rod. Here, battery, external source is responsible for charge over the rod, correct? Response, sir. So in electrolytic cells, external source is responsible for charge over the electrode. Correct, sir? External source is responsible for charge over the electrode. Yes, sir. Battery is giving electrons. Now that electrons got accumulated over the rod, therefore rod is negative. Or no? Any questions? Right. Now, if this rod is negative, as this rod is negative, in this solution, I have taken NaCl, Na plus and Cl minus, which will be attracted towards the rod. Na plus. So cations are attracted towards a rod, then it is called cathode. Is it clear? So tell me, what is the charge of cathode here? Here charge of cathode is negative. Correct, sir? Correct? Now see above case. What is the charge of cathode? Right? Now tell me. If you say cathode charge, or by seeing charge, if you decide whether it is cathode or anode, it is right or wrong? Wrong. Reason? Sometimes cathode gets positive charge, sometimes cathode get negative charge. If external source is responsible for charge of cathode, then it should be negatively charged. If chemical reactions are responsible for charge of cathode, then cathode must be positive charge. Is it clear? Any questions? Right? So if battery or external source is responsible over the charge of cathode, for sure cathode must be negatively charged. Otherwise, cathode must be positively charged. Any questions? Any questions? Right? No. Cathode is negatively charged. Means cations are attracted towards cathode. Cathode charge is negative, na? So cations get attracted towards cathode or not? So cations are discharged at cathode. Can I say it? Can I say correct or not? Cations are discharged at cathode. Correct or not? Correct? So cations are discharged means cations are gaining electrons. Gaining of electrons is called reduction. Means what happens at cathode? Therefore, reduction occurs. Correct, sir? Response, sir. Do you have any questions in it? Do you have any questions in it? No questions, no? Now go to above case. What happened at cathode? What happened at cathode? Now tell me, define cathode. Electrode at which reduction occurs is called cathode. That is correct definition. Don't ever say cathode is either positive or negative. So you should not decide an electrode as cathode by seeing its charge. But you can decide whether it is cathode or not by looking at the reaction. If a reduction reaction is happening, definitely it is cathode. I don't care what is the charge. Sometimes because of positive charge reduction occurs, sometimes because of negative charge reduction occurs. Is it clear? Any questions? Online, do you have any questions about this?
No, sir. No, sir.
Remaining students, Jeevataran, Ritika, Vasumati, Vinita, Santoshini. All these are girls, huh? Vinoda. So many girls are there. No one is responding.
No doubt, sir. Yes, sir. No doubt, sir.
Right. Boys, Saifuddin, Jeevatarun.
No doubt,
What
sir.
is his name? Roslyn Shelley. Roslyn Shelley, girl.
No doubt, sir.
Okay, girl. Then Jagadish.
No doubt, sir.
Right. Now, again. Please, listen. Please. So, cathode is negatively charged. That is, cations are discharged at cathode. That means reduction occurs at cathode. Right? Now, same way regarding anode, sir. Anode. Anode. Positively charged. That means anions are discharged at anode. Anions are discharged at anode. Anions are losing charge means anions are losing electrons. Loss of electrons is called. So therefore, oxidation occurs at anode. Do you have any questions in it? Now tell me, what is the direction of flow of electrons? What is the direction of flow of electrons? What is the direction of flow of electrons? One fellow joined just now. Huh? Till now, 16 students are there. Now, strength is increasing. Class is about to get completed. Maybe parents are returning from job to home. Correct? So they should feel like my kid is attending lectures perfectly. Now I will make sure that parent also listens to this. One fellow joined just now. Till now he is absent. Right. Again gone. That fellow gone. Right. Now listen. What is the direction of flow of electrons, sir? Anode to cathode. Why? Observe the direction of flow of electrons. Battery is giving electrons, right? Correct or not? Battery is giving electrons. Say something. So from negative terminal of battery, electrons are flowing into the solution. Now circuit has to be closed. So those electrons has to pass through this and has to come like this, correct? Then only circuit is closed, right? So what is the direction of flow of electrons? Cathode to anode in the solution, anode to cathode in the external circuit. Right. Here, man, in external circuit. In external circuit, it is from anode to cathode. In the solution, cathode to anode. Right? I am talking about only external circuit. In external circuit, what is the direction of flow of electrons? Anode to cathode. Now see here. What is the direction of flow of electrons? Where? Here. What is the direction of flow of electrons? In the external circuit, not in the solution. In the external circuit. Same only. Is it from anode to cathode or not? Same or not? So here also, anode to cathode. Correct? So I'm writing that point. Flow of electrons is from anode to cathode. In brackets, I am writing external circuit. Respond, sir. So this statement remains true irrespective of the type of cell. I don't care whether it is electrochemical cell or electrolytic cell. In both cells, it remains the same. In both cells, at cathode, reduction occurs. In both cells, at anode, oxidation occurs. Right? Any questions? Then what is the direction of flow of current? If you want to attend any natural calls, go and attend, come back. Don't make any noise here. Right? Listen. Now listen, sir. Listen, sir. Why we call it as electrolytic, lysis, homolysis, heterolysis? What do you mean by it? Lysis means breaking. Lytic means breaking. How I am breaking? By passing. So by passing electrical current, I am going to break ions in that electrolytic solution. That's why it is called electrolytic cell, or I call it as electrolysis process, right? Electrolytic cell, or I call it as electrolysis process. Right? Now I am taking one example. Electrolysis of NaCl aqueous using inert electrodes. I am going to discuss only exceptional cases, sir. Based upon this preferential discharge order, in all cases, you will say which cathode, at cathode which will be discharged, at anode which will be discharged. By observing this preferential order, you can give. Right? Now I am trying to explain where your order fails. Only those special cases, exceptional cases we are discussing. Remaining all cases, you will give the answer by seeing that order. Right? Only exceptional cases I am discussing. Only 5 such exceptional cases are there. Those 5 courses I will discuss in detail. Right? Now, I am doing electrolysis of NaCl aqueous using platinum electrode. Now tell me, what is electrolyte here? What is electrolyte here? NaCl aqueous. From this electrolyte, I will get cations and anions. Now tell me, what are the cations available? Or what are the ions available? Na plus ions. Don't we have H plus ions? Why I am writing directly H plus ions? Because enthalpy of formation of H plus is 0, so I can write it freely. Now, what are anions available? Cl minus. And I am writing H2 also. Why, sir? Why, sir? Why I wrote H2O specially? Oxygen. From water, oxygen can donate lone pair of electrons, na? Say something. Yes or no? Right? If I consider dilute solutions, right? Now I am taking platinum cathode. At cathode, what should happen? Reduction or oxidation? Reduction. Which will undergo reduction? Cations or anions? What is the charge of cathode? Negative. What should happen? Reduction. Respond means gain of electrons. Which will gain electrons? Na plus or H plus? Preferential discharge. Preferential discharge. Which will?
H plus.
Na plus or H plus? What I told you. Na plus will never discharge if there is water. Correct? Or as long as H plus is available, Na plus will never be discharged. Correct or not? So what happens at cathode? H plus ions gain electrons to produce H2 gas. Correct? Huh? Now platinum anode. Now among Cl minus and H2O, which will be discharged readily? Hey, which will discharge readily? So H2O. What happens at anode? What is charge? Positive. What should happen? Oxidation. Oxidation means loss of electrons. So H2O loses electrons to produce 2H plus half O2. Do the reaction got balanced or not? Check. Correct or not? Say something. Whether I am writing same reaction or not. Reverse of it. Reverse of this reaction, man. H2O gives H plus electrons plus O2. They took 2 H2O. I took only 1 H2O. That's why I wrote it as 2 electrons, 2 H plus, half O2. Right? It's a discharge potential value is only minus 1.23. Why I'm writing minus 1.23? I am oxidizing it. Chlorine discharge potential is minus 1.36. Clear? Any questions? Right? Response, sir. Now, what ions are left in the solution? Na plus ions are left and Cl minus ions are left. What is lost? H2 is lost, O2 is lost. Means H plus is gone, water is gone. So what happens to amount of water? Decreases. If amount of water is decreasing, what happens to concentration? Increases. Means during electrolysis, what happens to concentration of NaCl? Concentration of NaCl increases. That square bracket indicates concentration. Concentration of NaCl increases. Clear? Any question, sir? If it keep on increasing, at some point, I should not call it as a dilute solution. What is this? This is electrolysis of dilute NaCl solution. Huh? If I keep on doing electrolysis, after certain point, I should not call it as dilute. I should call it as concentrated. The moment it becomes concentrated, it gets reversed. That's what I told you. First exception, exception 1. Note. Right? If it is not dilute solutions, if this is not dilute solutions, if they simply write NaCl aqueous in brackets, not dilute, then Cl minus is discharged. Cl minus is discharged preferential to H2O. If a concentration is not dilute, instead of Cl minus, instead of H2O, which is discharged preferentially, Cl minus. Right? Reason. Just try to understand this. Try to understand this. You know Van Hoff equation, na? Delta G equal to delta G naught minus RT ln, plus RT ln Q. Right? Instead of delta G, I am writing minus NFE is equal to minus NFE naught plus RT ln, instead of Q, concentration of product upon concentration of reactant. Right? Divide the total equation with minus NF. E equal to E naught minus RT by NF ln concentration of product upon concentration of reactant. Correct? No. See this reaction. Cl minus, at what happens at anode? Cl minus should convert into Cl2 plus 2 electrons. This should happen actually. This is product. Correct? Means instead of product, I am writing concentration of Cl2. Instead of reactant, I am writing concentration of Cl minus square. Correct? If concentration of Cl minus square is increasing, that's what now I am saying. If it is not dilute, means concentration of Cl minus is more. If this denominator is more, what happens to this log value? Negative. And if denominator is more, log value becomes negative. If log value is negative, what happens to this sign? If this becomes positive, what happens to E? Becomes greater than E naught? Say something. E becomes greater than E naught or not? If E becomes greater than E naught, what happens? If E becomes greater than E naught, because of E naught, water is getting discharged better than E naught of Cl minus. Correct or not? Because of E naught only compared to Cl minus, H2O is getting discharged. Correct? If concentration of Cl minus keep on increasing, at some point, its E value becomes greater than its E naught. When it becomes greater than E naught, definitely it will cross 1.23 value. Reverse. Where is chlorine? Where is chlorine? Here. 1.36, 1.23. Right? This value is negative now. Minus 1.36. This is minus 1.23. What should happen to this value? This value should increase. This value should increase means it should become less negative. E naught value is. This is reduction now. Reduction value is 1.36, man. Oxidation value is minus 1.36. Correct or not? E naught value is minus 1.36. And what about this value? This value is becoming positive. This value is becoming positive. Then what happens to E value? From minus 1.36, it will become minus 1.35, minus 1.34, minus 1.32. Correct or not? At some concentration of Cl minus, it may become less than minus 1.23. The moment it becomes less than minus 1.23 compared to water, which has to undergo oxidation, chlorine. Is it clear? Right? So till that concentration, which is oxidized preferentially, water. At that concentration, instead of water, Cl minus will start oxidized. Is it clear? That's why what I told you. If it is not dilute, means if it is concentrated solution, after certain concentration, instead of water, Cl minus gets discharged preferentially. We call this as over voltage. How I got that over voltage? How I got that extra voltage? Because of this. Are you able to understand? Any questions? Right? Understood or not? So, if it is not dilute, now tell me what should happen at cathode? Is there any change in cathodic reaction? Is there any change in cathodic reaction? At cathode, whatever the reaction is happening, is there any change? No, right? So therefore, cathodic reaction, platinum cathode reaction remains same. What is it? 2H plus, gain 2 electrons to produce H2 gas. Now at anode, say sir, 2Cl minus gives rise to Cl2 gas plus 2 electrons. Correct? Now during electrolysis, What? What is left? What is left? What is left now? During electrolysis, H plus is gone, Cl minus is gone. What is left? Na plus in water, right? Na plus react with water to produce NaOH. Correct or not? Sponsor. So during electrolysis, what happens to pH of the solution? Because of formation of base. In first case, during electrolysis, what happens to NaCl concentration? Increases. What is pH of NaCl solution? 7 only. Reason? NaCl is salt of strong acid, strong base. Right? They cannot hydrolyze water. Right? Response, sir. So at 25 degrees centigrade, its pH remains 7. But here during electrolysis, pH of solution increases due to formation of what? NaOH aqueous. Clear, sir? Right? Now, which is liberated at anode? Chlorine gas. At cathode, H2 gas. Correct? Now see this diagram. See the diagram carefully. What they have given at anode? Cl2 gas is liberated. Don't get confused, huh? Why I'm getting these arrows? Who asked that? Okay. Remove this arrow also. Don't get confused, sir. Here H2 gas is liberated. Here chlorine gas is liberated. Means what type of NaCl aqueous solution you have taken? Dilute or concentrated? Just now we discussed, man. Concentrated. If it is dilute, what we may get at anode? Oxygen gas. At cathode, H2 gas only. Correct? If it is dilute, I will get O2 at anode and H2 at cathode. If it is concentrated, I will get chlorine at anode and H2 at cathode. Exception 1 over. Now exception 2 means note 2. Note 2. I told you there are only 5 notes, 5 exceptions. First exception is over. Any questions regarding first exception? What do you mean by over voltage? Just now we discussed. Do not answer also. Huh? See, over voltage. Reason? Read it. Over voltage in electrolysis refers to the extra voltage needed to drive an electrochemical reaction beyond the theoretically potential required for a reaction to occur. Theoretically, which has to happen, water, than Cl minus. What I have done, by increasing concentration of Cl minus, I am changing the voltage so that instead of water, Cl minus got preferentially oxidized. Therefore, I call that voltage as, understood, right? This additional voltage overcomes the barrier, like activation energy, like resistance, allowing the reaction to proceed, right? No. Over voltage during electrolysis of Cl minus. In electrolysis of brine solution, Cl2 gas is produced at anode, not oxygen, due to, understood or not? The same thing we discussed or not? Due to over voltage. Over voltage is the extra voltage needed to overcome the activation energy and cause the reaction to occur. The over voltage for chlorine gas formation is lower than that for oxygen formation, or it should become, that should become less than minus 1.23. But actually it is minus 1.36. By changing the concentration of Cl minus, we are making this to become less than minus 1.23. Correct or not? Right? Lower than that of oxygen formation, even though the standard electrode potential for oxygen oxidation is slightly lower than that of chlorine. Actually, oxygen formation voltage is less than chlorine, but I am changing its voltage by changing the concentration, and I am making the two undergo oxidation preferentially. That's what we call it as over voltage, right? Now, if they ask you why chlorine gas is evolved at anode relative to oxygen, I will not explain all this nonsense. I will say over voltage. What is over voltage? Already you know. By changing concentration, I am changing the. Are you able to understand? Response, sir. So here what I am writing is simply over voltage in brackets. Will you understand? Will you understand the meaning of this now? Instead of writing all this nonsense, if it is not dilute, what I will say, due to over voltage, chlorine is liberated at anode instead of oxygen. This is it. Yes or no? Right? Now, second note. Second note. Very, very important point, sir. Mercury cathode. Here, what cathode we are using? Platinum, inert cathode. Instead of inert cathode, instead of platinum cathode, what I am using now? Mercury as cathode. If mercury is used as cathode, Na plus is discharged preferential to what should discharge actually? H plus. Right? If I use mercury as cathode instead of H plus, which is getting discharged, Na plus. Reason? Na plus is readily soluble in mercury. Sodium amalgam. Are you able to understand? If I use mercury as cathode, now see this. Na plus and H plus has to compete. Which will win the race? H plus will win the race. If there is competition. If Na plus is already inside the electrode, there is no competition. No? Are you able to understand? See, this is electrode. This is electrode. Electrode is negatively charged. Now there is H plus, there is Na plus. Now, as this is negatively charged, H plus will move towards cathode, and Na plus has to move towards cathode. Among these two, which will win the race? H plus win the race, right? If Na plus is already inside the finish line, cheating, na this is. Alright, it is cheating, cheat code. There is no race at all. Na plus is already inside the electrode. Now, if you keep race, Who will win the race always? Over. So if I am using mercury as cathode, so Na plus will dissolve in it. Sodium will dissolve in mercury. If it is dissolved in mercury means Na plus is already inside cathode. If it is already inside cathode, who will win the race? Obviously, over. Means which is discharged preferentially. Over. Are you able to understand? So second cheat code. What is it? What is it? If I use mercury as cathode, Na plus is discharged preferential to H plus. Reason? Reason? Due to sodium amalgam formation. Right? Now during electrolysis, what happens? Now during electrolysis, what happens at cathode? Now tell me, mercury cathode. What happens, sir? What happens, mercury cathode? Na plus gain electron to form Na. Correct? Of course, I will write Na amalgam. Will you understand or not? Will you understand or not? Why I am writing, sir? In reactant side, there is no mercury. Why you are writing mercury? Rod itself is, cathode itself is mercury. So that sodium is dissolved. So sodium amalgam. Clear? Now, I don't care about anode. So whether it may be mercury anode, graphite anode, or lead anode, or platinum anode, who cares? Right? So I am not writing anything. Simply I am writing anode. What happens at anode? Now the question, whether it is dilute or concentrated. If it is a dilute, O2 is liberated. Yes or no? If it is a dilute, O2 is liberated. So what is left in the solution now? H plus Cl minus. So during electrolysis, pH decreases due to formation of, correct? If it is concentrated, what happens at anode? Cl minus is liberated. What is left in the solution? H plus and water, right? Enthalpy of formation of water, H plus is 0 in water. So I don't care. So simply I will write water only. Na plus is gone, Cl minus is gone, means H2O is left. So during electrolysis, pH doesn't change. Concentration of NaCl decreases. Na plus is gone. Chlorine is also gone. Means NaCl is gone. So concentration decreases. Is it clear? Response, sir. Response, sir. Alright, I will do one thing. I am writing here concentrated or dilute. Your wish. Dilute, huh? Okay. Dilute NaCl aqueous. What happens? Dilute NaCl aqueous. Dilute. What happens? Dilute. H2O. Use rise. 2 electrons. 2 H plus plus half O2. What is left? What is left? H plus is left. Cl minus is left. So therefore, during electrolysis, pH of solution, pH of solution decreases, right? Due to formation of HCl, right? Third exception I will not write. Why, man? Already third exception is discussed above. Why to write mercury cathode concentrated NaCl? Why to write it? You understood, na? Right? Say something. Now, another example, sir. Electrolysis of 1:1 molar mixture of 1:1 molar mixture of Na2SO4 and H2SO4. Na2SO4 and H2SO4. This is 1 mole. This is 1 mole. If I take 1 mole, means it is nothing but sodium bisulfate Na2SO4 plus H2SO4. Exchange cations, sir. Bring one H plus here and bring one Na plus here. What do you get? 2 moles of NaHSO4, na? If I take one mole of this, 1 mole of this, means indirectly what I am taking? Indirectly I am taking NaHSO4, right? Or ammonium bisulfate, or %50 H2SO4. Meaning of this is 1:1 molar Na2SO4 and H2SO4. Meaning is 50% this, 50% this. That is the meaning, na? So whether they say 50% H2SO4 or 1:1 molar mixture of Na2SO4 and H2SO4 or ammonium bisulfate or sodium bisulfate or ammonium sulfate with H2SO4, everything means same, right? So electrolysis of this using electrodes, either platinum electrode, lead electrode, graphite electrode, whatever electrode you want, you take. Don't take graphite. Exclude graphite. Except graphite, take any other electrode. Right? So I'm saying using inert electrodes. This is fourth exception now. Hey, third exception. What is it? Using mercury cathode and concentrated NaCl. So I am not discussing that. You already know it. So directly I go on for fourth. Clear? Now see this. If I am considering sodium bisulfate, right? Either this or if I take ammonium bisulfate, NaH4 SO4 plus H plus. Sodium bisulfate, Na plus HSO4 minus. What are the cations and anions available, man? Na plus HSO4 minus. Here, NaH4 SO4 minus and H plus. Say something. Okay, H plus NaH4 SO4. Correct? Here, H plus HSO4 minus. Right? Clear? So I am considering this. So what is electrolyte? NaHSO4 aqueous. What are the ions available? Tell me the ions. Na plus ions, correct? Correct? H plus ions, HSO4 minus, and water. Respond, sir. At the moment I say aqueous, I will take H2O always. Clear? Any questions? Right? NaHH4 separates into Na plus and HSO4 minus. Na plus HSO4 minus. Due to enthalpy of formation of H plus is 0, I will write H plus and I am writing water. Clear? Correct? Now at cathode. Cathode. I am writing platinum cathode. Now tell me, sir, what happens at cathode? I am not taking mercury cathode. I am taking platinum cathode. If I take mercury cathode, I will reduce Na plus. I am taking platinum cathode. What should happen? 2H plus gain 2 electrons to produce H2 gas. Right? Now, lead anode or platinum anode. Generally in industry, we use lead spiral. Right? One wire surrounding that glass plate, glass tube, which is surrounded with platinum wire, lead wire. And this kept in very cold condition. Industrial. We are not bothered about industrial preparation now. So here I am directly taking platinum anode. In industry, they will take lead spiral as anode. Right? Now, among these two, there is competition. If it is SO4 2 minus, who will win the competition? Water. See. If it is SO4 2 minus, who will win the competition? Water. I am taking HSO4 minus. That too high concentration at 50%. Right? Therefore, that will dominate H2O. Special case. Right? So which will undergo oxidation? So 2 moles of HSO4 minus gives rise to form 2 electrons plus H2S2O8 aqueous. Understand? Clear? What we call this as? Marshall's acid. What we call it as? Marshall's acid. Have you recalled anything? In class 11th, we discussed hydrogen's compound chapter or not? In hydrogen's compound chapter, we discussed this. Yes or no? Huh? What you will get at anode? By looking at this reaction, you need to recall it. This reaction we studied in hydrogen's compound chapter. What is this? Industrial method of preparing hydrogen peroxide. I will show it. So good students we have. First step. 24-25 batch. Correct? FS hydrogen and its compounds chapter. In that, we are going for hydrogen peroxide preparation and properties. Hydrogen peroxide preparation, right? After that, electrolysis of, what is it, sir? 1:1 molar mixture of ammonium sulfate and H2SO4 or ammonium bisulfate. Observe what we have taken. What is it? Lead spiral. Correct? Which is used as anode. Platinum used as cathode, which is electrolyte, 50% sulfuric acid, and this process is done in an ice bath. That's what I told. industrially? Say something. Now what happened at anode? What we got? H2S2O8. What is it? Marshall's acid, or it is also called as per-disulfuric acid, that immediately reacts with water. Water is present or not? To form Carros acid, which will react with water again to form hydrogen peroxide. So, industrial method of preparing hydrogen peroxide. Yes, sir. So, what you will get here? H2S2O8 undergo hydrolysis to form H2SO5 plus H2SO4. This H2SO5 again undergoes hydrolysis. What we call this H2SO5? What do we call this H2SO5? Carros acid. Or we also call it as persulfuric acid. Marshall's acid is also called as per-disulfuric acid. This is persulfuric acid. Now what you got? H2O2 plus H2SO4. Right? So what is obtained at anode? What is obtained at anode? Hydrogen peroxide. So exception 4 is over. What is it? If I am doing electrolysis of 1:1 molar mixture of sodium bisulfate or ammonium sulfate and H2S4 or ammonium bisulfate or 50% sulfuric acid, what you should get at anode? Hydrogen peroxide is obtained at anode. Over. Next, last exception, exception number 5. I will stop the discussion. Right? We will discuss this 5th exception in next class. After that, 2 laws are there: Faraday's first law, Faraday's second law. That ends electrolytic cell path. Very, very easy. Right? Any questions do you have in today's class? Yes, sir.
No, sir.
Next exception also, sir. Just I will give the side heading of it and I will close it. All right. Electrolysis of M plus N aqueous using M anode. What you understood? Electrolysis of M plus N aqueous using M anode. When I am doing
Electrolytic
electrolysis
refining
of any
acid.
electrolytic solution, whatever metal is present in that solution, same metal I have to use as anode. If I am doing electrolysis of copper sulfate solution, I have to use copper rod as anode. AgNO3 solution, silver as anode. Right? This is the next exception. Right? So example I will take, that is electrolysis of CuSO4 aqueous using copper anode. Using copper anode. Right? So this we will discuss in next class. This is the major best idea to get 100% pure metal. This is the better idea. We call it as refining process, electrolytic refining process. In metallurgy, almost every metal, after getting crude metal to get 100% pure metal, we follow this method. We call it as electrolytic refining method. Right? Right? I will stop. Right, sir? Online? Anyone alive?
Yes, sir.
Yes, sir.
Yes, sir.
Right, sir.
Yes, sir.
I will end the session. All right, listen, please. When is your first exam? First UT? June 11. Actually, what they have done is they thought in May we will give holidays, but at Akash, particularly at Madurai, don't expect holidays. So there are no holidays in the month of May, right? So mostly by next week, I will complete this chapter. After this chapter, I will directly go to chemical kinetics and nuclear chemistry, right? After that, P block, because solutions and colligative properties, electrochemistry, chemical kinetics, and nuclear chemistry. If you complete these three topics, three chapters, physical chemistry of class 12th is over. Clear? For JEE mains. For advanced, a few chapters are deleted. One chapter is solid state. Second chapter, surface chemistry. These two chapters are deleted, right? So first what we will do is, first we will complete topics related to chapters present in mains, right? After this, I will go and complete P block first. Reason, P block is very lengthy. In organic chemistry, huge theory is there, but it will be very easy. So first we will complete P block, D and F. Right? If I complete P block and D and F chapters along with chemical kinetics, up to UT2 syllabus is over. Right? Then I will come back to solid state, surface chemistry. Right? Response, sir. If I complete P block, D and F block, listen. P block is deleted actually. P block is deleted from your mains. D and F block is present. If I complete D and F block and coordination compounds, inorganic chemistry of class 12th will be over. See how much easy class 12th is. 11 syllabus is more, 12 syllabus is very less. Electrochemistry, solutions and colligative properties, chemical kinetics and nuclear chemistry. Physical is over. D and F block, coordination compounds, qualitative analysis also there, but it is practical. Qualitative analysis is your practical in organic chemistry. I will complete that also. If I complete these three, inorganic of class 12th is also over. Means 60% portion of class 12th is over. If I complete 6 chapters, right? Remaining is only organic. Alkyl and aryl halides, one chapter. Alcohol, phenols, ethers, another chapter. Aldehydes, ketones, carboxylic acids, amines and nitro compounds, very small chapter. If I complete these 4, total syllabus is over. Right? Physical 3 chapters, inorganic 3 chapters, including practicals, 4 chapters of organic. That's all. Organic total syllabus of class 12th will be over. But deleted portions are many. Solid state, surface chemistry, P block, then biomolecules, polymers, chemistry in everyday life, practical organic chemistry. So how many deleted chapters? 7. How many chapters are present in syllabus? 10. 10 chapters are in syllabus. 7 chapters are deleted. Right? Means I will need to take more time for completing deleted form. Almost equal time I need to spend for completing deleted form. That's why what I will do is, first I will complete your syllabus which is present, right? Then I will concentrate on deleted portion. Reason, sir? Once your school gets started, what you will do? You will don't care about what is happening here. Correct or not? So first, before your school starts, let me complete at least 50% of syllabus which is present for your boards. Right? Later we will discuss slowly. Right, sir? Right? Go. अरे अरे attendance man. You